On for the next speaker. In terms of externally connected smart contracts, everything's kind of connected in this new world. This subject is connecting blockchain in the real world with Sergey Nazarov. Sergey is the CEO of Chainlink, a leading blockchain middleware company. Chainlink works with banks, insurance companies, and large technology firms, including SWIFT, of all things. So if any of you have had an international wire transfer on a weekend that takes 3 days, maybe they recognize the power of blockchain. We'll see. Due to Chainlink's recent acquisition of Town Crier, Chainlink is now widely considered to be the foremost mechanism used by many of the leading smart contract development teams and employees to connect to other institutions. Welcome, Sergey.
Great. Thanks very much. Thank you. Yep. Hi, everyone. Good to see you here. Thanks for your interest in this question. So fundamentally, the question we're going to be examining is the smart contract connectivity problem. This is the problem where smart contracts, in this case, based on this conference theme, essentially centralized finance type contracts, can't get access to external data. Once again, in the case of this conference, that being market events. Now, this is a slightly abstract problem, so I think it's useful to both put it in a historical context and to show how it practically impacts the evolution of decentralized finance. And the impact it has, I think, is very significant. So, historically speaking, when this space started out, the idea of programmable money was basically Bitcoin multi-signature. It was the fact that you could program money to move on the basis of multiple signatures. This is in and of itself was an exciting concept, and this drew a lot of people into the space, including me. Then you had an evolution into something called protocol-based smart contracts. This is when every time you needed a new smart contract, you literally needed to go to protocol developers. They needed to write the contract and publish it as part of their protocol. Some of the protocols that were existent at that time had the ability to generate tokens, and they had the ability to do decentralized exchange. This is about 2013 and 14. This is kind of the first wave of tokenization, decentralized exchange. This is kind of how the whole space began. The whole space basically began because you moved from some very minimal set of programmable money features to a more robust set of programmable money features, where with a lot of effort, people could generate their own tokens and use a DEX that had various flaws. Then what happened was that Ethereum took us from these protocol-based smart contracts, where every time you wanted a new token or a new protocol change or something, you had to go through a lot of pain, and they made scriptable smart contracts, which, albeit they did a very good job at, and now we're in a situation where anybody with some amount of programming knowledge can sit down and script up a token to represent what they wanted to represent, to function how they wanted to function, to move how they wanted to move, assuming they abide by relatively unclear security dynamics. But at the end of the day, this shift in functionality and in features took us from a completely nascent, mostly non-interesting, double-digit millions of monthly of daily volume space into billions of dollars of daily volume space, because everybody can come in via new features and generate tokens. So the reason we're all in this room today is because people were given a feature set to generate the tokens that created the value that's being moved around. If this increase in feature capabilities didn't happen, this wouldn't have happened, right? So then the question logically becomes, what is the next meaningful step in how this feature set evolves? Like, what is the similar magnitude step from I need to go through a ton of pain to generate a token to now I can script up my own token in a week? Essentially, we think it's going from tokenization 2.0 and DEX 2.0 scriptable smart contracts to what we call externally aware smart contracts, or full smart contracts, or what the people on the previous panel talked about as being programmable. So essentially, if you think about the way the vast majority of actual financial products work, they are programmable, right? They react to futures contracts, react to market events, as do many other derivatives. There's basically an entire category of financial contracts that the only way they come into existence is if they can meaningfully interact with a market event, such as knowing that a price changed. Until contracts can know that prices have changed or that some kind of event out in the real world has occurred, those contracts can't come into existence. Now, this lack of capabilities, I think, affects the majority of financial instruments. So I think right now what we can do is we can make static tokenized assets that don't react to any meaningful market dynamics, price changes or delivery of goods or insurance payouts or anything like that. And I think if you look historically at the securities industry, the vast majority of actual financial products do have something to do with market events. So fundamentally speaking, as long as this problem persists, we don't have access to 80% of the contracts that we could generate in the decentralized finance space. That to me sounds pretty significant. That's why I feel this problem is significant. I think it's just useful to put this kind of in perspective that if you look at the actual financial products that the decentralized finance space hopes to replace, tokenizing an asset that doesn't react to market events is a small subset of everything that the decentralized finance space could replace, right? So then the question becomes, okay, how do we solve this problem? How do we enable smart contracts to interact with market events so that we can go beyond these static tokens that, the token represents a house and I give the house to you, or the token represents some asset that never needs to know about price changes or anything like that. So fundamentally speaking, this is what we focus on. This is why, earlier as mentioned, we are the leader in connecting these smart contracts to the relevant data sources for certain enterprises and other customers. Essentially, we feel that blockchain middleware provides the necessary inputs and the necessary outputs. So this actually extends beyond getting the data to the contract in order to make the contract at all. And it also extends for the contract to be able to settle or pay in whatever format it wants to pay. So there's actually two sides of this. One side of connectivity is, can I make a futures contract that knows about market price changes on a daily basis so I can mark to market and have a futures contract? And then the second part of it is, how do I settle that contract? And then I need outputs. I need to pay out that contract. And until everybody that wants these types of contracts wants to accept cryptocurrency, we need a bridge both for the contract to know what's going on relative to the market event it's about and to settle in the method that people want it to be settled in. So fundamentally, in building these types of connections, we've found one very important thing to be critical, and that is that you want end-to-end reliability. So what that means is that you value the smart contract because it's so reliable, because it's run in a method and a manner that is not gameable, that provides an extreme degree of reliability. This extreme degree of reliability needs to, as you expand what a smart contract does, you need to expand that outwards to all the systems that influence it. So this is the fundamental problem of how do we make these more complex contracts, futures contracts, derivatives, all these other contracts that actually provide more value because they're programmable, because they're not just about static assets. But while we do that, how do we retain the security and reliability of the system that we have, because we value that system for that reason, right? So how do we expand the capabilities but retain the security and key properties of the system? Fundamentally speaking, what we probably don't want to do is we don't want to do something called a centralized oracle. Centralized oracle is one node that triggers a contract running on a node network made up of multiple nodes. This fundamentally goes against the security model of our space because you once again have a single point of failure, and now all the problems you had from a single siloed point of failure expand out from the contract layer into this oracle layer. Fundamentally, the solution to this is to have a multitude of node operators, is to simply apply decentralization that solve the smart contract state change and state storage problem and expand that concept of decentralization to the oracle mechanism, which will now be able to reliably trigger the contract. And once you apply that to the oracle mechanism layer, you can then apply it to the data layer as well. Fundamentally, as an example, just kind of for this conference to put this in some clearer context, let's say we have a futures contract. It needs to be marked to market on a daily basis in order for settlement to happen. The futures contract can be in the form of a token. Congratulations, we've just, by being able to feed it multiple data feeds that are reliable and running the futures contract in a tokenized form in a reliable environment like Ethereum, we now have an entirely new tokenized financial product that's worth, as an industry, hundreds of billions of dollars. And we've been able to do that in a way that maintains the reliability guarantees of a system like this. Then once the contract is able to properly settle, acquire the data it needs and settle, we need to settle it, which means we also need an access point into all kinds of retail or institutional payment systems or even other crypto payment systems. So fundamentally, this is the key problem we're working on solving, and I think solving this problem will greatly expand what smart contracts, and specifically decentralized finance contracts, are able to do. Like if you ever wondered why don't we see more complex, interesting products while I'm hearing about programmable money, like why don't I see all the programmable stuff happening? It's because to make it programmable, you need inputs. And then for the programmable thing you just made to be purchasable by people that actually want to purchase it, it usually needs to settle. It needs to pay them in the manner they want to be paid. This has been our fundamental experience. And we think solving these two problems will, we hope, and we're working very hard to make it so that enabling these inputs and outputs creates this fundamental increase in features and therefore increase in what people build. That's kind of the goal of our body of work. So thank you. Yep, that's it. Okay.
Thank you, Sergey. Okay, with great pleasure. This section is Wyoming Blazing the Trail. Honored to